Hi, this is Darren with the Mississippi State Chemical Laboratory, and today I'm going to be showing you how to use our ammonia meter. Now we have an analysis where we check for ammonia in water samples. We don't do it that often, but this is a crucial part of our Kjeldahl total nitrogen analysis, which we do much more often. So I'll get started and show you how to set up the probe. It's a little bit different than our pH probe over there, and then how to take measurements with it. Maybe the first thing that you need to know about our ammonia meter setup is that all of the stuff you need for it is in this drawer underneath it. So in here we have our membranes that I will show you how to use, and our electrode filling solution, which works the same way that the electrode filling solution on the pH electrodes works. Additionally, there is this user guide, which is extremely helpful in telling you how to set it up. Most of what this video is going to be on is just recreating the instructions in this. If you'd like a written version, it's right in here. Here is our setup for the ammonia meter. What you may notice at first is that this electrode is actually just sitting out dry, and that's maybe the first thing that differentiates it from our pH electrodes, where those are all a self-contained unit that needs to be kept in its storage solution at all times. This, if we're not going to use it for long extended periods of time, we will take the whole thing apart and let it dry out. Down here is actually the outer casing, and so when we put this together, we're going to have the filling solution in the outer casing surrounding this inner electrode. So off camera, I prepared a 10 part per million solution of ammonia. That's just going to be the short-term storage solution for the electrode once I have it constructed. And so to construct the electrode, we need to get our ammonia membranes. Open these up. We also have a set of tweezers because you want to try to avoid touching these with your hands as much as possible. One thing that is a little difficult with these membranes is that there are the actual membranes, and then there are sort of separator papers keeping them apart from each other. And the first thing you need to do is get the membrane and the separator paper separated. So it takes a little bit of a steady hand, but you can get in there. The membrane is the more opaque white, and then the separator paper is a little bit more see-through. So that's just trash now. Okay, so we have our electrode outer case. I'm going to take the little tip off. It just screws off. And then I want to place this against the teeth of the screw cap, and then hold it down with my thumb, and then pull this over the top, and then stretch it down with my other hand. So I really want to avoid touching that the top there, but I want to get it so that it is smooth. So I'm going to pull each side down a little bit to tighten it. You don't want to pull it too tight so that you're stretching the membrane out and you can see black underneath, but you want it to be a smooth surface. So once you have something like that, you can put the screw cap back on and screw it down. And if you did it right, it should be just very flat on the end there. You can't see any wrinkles, you can't see any tears. So that is what a good outer casing looks like. from here, all that's left to do is take the electrode filling solution, fill this up. I think it only takes about 50 drops or so. If you go a little bit over, you'll just get a little bit of spillage, and that's okay. So from here, I'm going to put this in and screw the top on. And then to make sure that there is filling solution completely surrounding the electrode, you pull on this. You can feel a little bit of spring pushing back on it, and it's ready to go. So until I use it, I want to store it in this 10 part per million solution for at least 15 minutes, and it says ideally you want to do it for a couple of hours before running it. This has been sitting for a couple of hours, so it should be pretty well equilibrated at this point. So now it is time for us to do our calibration. What I have, again, made off camera is a 0.1 part per million solution of ammonia and another different 10 part per million solution of ammonia. Again, those are both 100 milliliters, and it's important that your calibration standards and also your samples that you're measuring come in at around 100 milliliters to make sure it's consistent. I will also need a couple of magnetic stir bars, so I'm grabbing those from the drawer underneath the pH meter right now. And just going to plop those in. Okay, I'm gonna rinse off my probe, and I treat this very much like I treat a pH probe. I'll rinse it with deionized water, but I'm not going to dry it. I think this one doesn't run as much of a risk of a static electric charge added if you were to wipe it with a chem wipe, but I just like to be consistent. So we can set this aside for now. We'll want to keep this around because this is what we'll store the probe in when we're done. So I'm just going to set this aside. All right, and get my 0.1 part per million solution out. Start my stir bar. You want to set it so that it's stirring, but it's not, you know, completely violent and it's about to spill out of the beaker. Okay. To turn on the ammonia meter, there's this power button on the left. And we want to calibrate, so that is the F1 button right now. Cal, and it'll give you instructions that says rinse electrode and place into buffer. Press start F3 to begin. Before we do that, we have to add our ionic strength adjuster, which is this blue solution. It's mostly sodium hydroxide, and then there's also some methanol and a little bit of blue dye, just to make sure you remember you put it in or not. It has this top on here where if you squeeze the bottle, some of the solution will come up, and then when you let it go, it will drain down to a specified volume. And so we have this set, or it should be set at 1.5 milliliters. I think it's actually, no, that should be about right. It's just a little weird to look at on the tilted camera. Okay, so again, squeeze that up and then let it drain back down to where it's supposed to be, and then we can just dump that into our calibration standard. And put the electrode in and hit the F3 button to start the calibration. Now these measurements are often very long, so I'm going to stop talking and fast forward the video until this stabilizes. Okay, so it has been a few minutes and the screen readout finally stopped at 0.044. Our protocol on this apparatus is we want to keep measuring until it gives us the same measurement twice in a row. And that's just because it takes so long to equilibrate that the software on the instrument thinks it's done before it's done. So instead of hitting accept or edit, I'm going to hit F1 to retry this. And then if we look at that, see it jumped from 0.044 to 0.047. And so I'm going to keep doing that until it gives me the same reading twice in a row. It should take a little while. If you remember, this is a 0.1 part per million ammonia solution, and while it's not going to be exactly there because we need to recalibrate it every time, it's only about halfway to 0.1 currently with the previous calibration. So I'm going to keep doing this until it finally stabilizes. So it has now stabilized at 0.050. It's given me that reading twice in a row. So now what I want to do is tell it this is actually a 0.1 part per million solution. So instead of hitting accept in the middle, I'm going to hit F3 for edit and tell it this is 0.1. And then F2 is accept. Okay, so now it has the first point. We only do a 2-point calibration with our 0.1 and our 10. So I can set that aside for now. I can bring the 10 in. I'm gonna rinse off my probe with deionized water. Add in my ionic strength adjuster to my 10 ppm solution. And then once again, so now F1 is escape, which is basically get out of this calibration. F3 is cal done, which is to say I've calibrated all of my points and I want to use this as my calibration. I've only done one, so that's not what I want to do. F2 is next, so I want to hit F2, and then it gives me instructions again. Rinse the electrode, place it in the buffer, press start, F3 to begin. The higher concentrations typically get there a little bit faster, but I think I will still cut the video and now resume after I've gotten a stable reading of 2 of the same reading in a row. Okay, I've now got a stable reading at 5.9 part per million. It's given me that twice in a row. It's low, right, but actually not super surprising because my 0.1 was reading at 0.05, so about half, and this one is reading a little bit above half of what it should. So now, again, instead of hitting accept, I'm going to hit edit and tell this that this is a 10 ppm sample, and then hit accept. And now, again, we have escape next and cal done, and so since it's only a 2-point calibration, I'm going to hit F3 for cal done. And it's good to look at this average slope. It's showing me, I don't know if you can see it on the video, it's showing me negative 57.8 millivolts per decade. It should be around negative 59, so that's not too bad from where it should be. So now what we can do is do a little measurement, and the measurement is done in very much similar way as the calibration. So I have now another 0.1 ppm solution of ammonia. I'm going to put another stir bar in. I'm going to rinse off the probe. Put in my 1.5 milliliters of ionic strength adjuster. Insert the probe into the solution. And now the 1 button also acts as the measure button. So this is how we can get to just regular measurement. And so my hope is that this comes in at a measurement near 0.1 part per million. You can see it's decreasing from the 10 where it was, but it will take a little while before it gets down to where it should be. Okay, so it has stopped at 0.13 part per million. I'm just going to hit the measure button again, and if the next measurement is also 0.13 part per million, that is what I would record as the final measurement. I'm pretty pleased with this. You know, it was supposed to come in at 0.1. It stopped, so it is at 0.13. That is 30% above, but considering this is working off of a 2-point calibration spanning 2 orders of magnitude of concentration, I would say that's pretty close. So that is our measurement done. If we had any more samples to measure, it would be pretty easy. We would get the water samples in. I would measure out 100 milliliters into one of these 150 milliliter beakers. You don't have to filter the water, you don't have to treat it, and in fact, if you were to treat it with something like nitric acid, that would skew your results. But it's just put the water in, put in the ionic strength adjuster, insert the probe, and then give it some time to equilibrate. So, done with this for now. And then those samples can just go down the drain. They are not especially acidic or basic. So gonna bring back my 10 ppm ammonia standard from before. I'm going to turn off the stir bar. If you leave that on, it's not that big of a deal. It's just wasting electricity, but it's not like a hot plate or anything. Rinse off my probe with deionized water and keep it in here. So if we are storing it just overnight, for instance, we can keep it in this 10 part per million ammonia solution, and I think up to a week. If you want to store it for longer than a week, that's when I would have to dismantle the probe, empty out all the filling solution, rinse it off, dry it off, and then let it sit dry until the next time I use it, at which point I will have to reconstruct it with a new membrane. All right, now let's get to the theory. So this should be a fairly quick one. I just want to talk about a few things that directly relate to our ammonia analysis. The first is almost a review from the pH meter discussion, where we have our beaker of liquid, we have our probe going in there, and then there's that membrane on the end. That membrane is hydrophobic, so it's not letting any of the water pass through it, but it does allow gases to pass through. In our solution, we have these ammonia molecules floating around. We also have ammonium, that is NH4 ion. One crucial thing about ammonia is that it exists as a gas, and so while it can stay dissolved in water for some period of time, it will eventually escape. And so if you're just going to leave a cup of water out on the counter for a while and then come and try and measure the ammonia in it, you're not going to find any. It will all have left by that point. However, ammonium ion can stay in solution, right? This is just aqueous for indefinite periods of time. And what we want is to know sort of the totality. These are, for our purposes, essentially the same thing. They're what we want to measure for. That's what the role of the sodium hydroxide, the ionic strength adjuster solution does. So if you have your sodium hydroxide and you add it to ammonium, that hydroxide ion is a stronger base than this ammonium, and so it's going to strip one of those protons off. We're left with sodium ion, which we don't care about, a water molecule, and an ammonia molecule. And so now, after we've added in that ionic strength adjuster, we've converted all of this ammonium to ammonia, and have a couple of other things that we don't care about. At that point, that's when we want to measure this solution. If you wait too long between adding in the ionic strength adjuster and taking your measurement, you will see your concentration slowly dropping and dropping and dropping, and that's because this ammonia gas, which is currently dissolved in solution, is going to start escaping over time. As far as how the probe itself takes its measurement, so it has these ammonia molecules diffusing through that membrane, getting inside of there, and then inside of here there's a solution. I believe it's an ammonium chloride solution. And in there, almost the reverse of this will happen, where you have now a lot of ammonia and some water molecules, and then that ammonia will strip a hydrogen off of the water molecules and create hydroxide. So basically just these two things going that way and giving us those two things, and then it's measuring the concentration of hydroxide inside of the probe. So I hope that was a nice quick overview for how to take measurements with our ammonia meter, and also a brief look into what it's doing. Check back for the next video, which is going to be applying this ammonia meter and ammonia measurement to a more common analysis that we do, the total Keldol nitrogen analysis.